So, welcome to this first program, 2 week ATAL faculty blended faculty development program on advances in solar photovoltaic, and it's designed for e-vehicles. Okay, it is a very interesting program and it will be beneficial for all the stakeholders who are participating in this program. Uh, we have involved only the local people because generally what happens that in such type of programs many people far from the states, right from South India, join them eagerly. So the AICT this time wants that the local candidates should join it and enhance their knowledge. So this FDP was being sanctioned towards advances in solar photovoltaic and design for e-vehicles. I myself, Dr. Vikramaditya, Principal Coordinator of this FDP, and I am also the Chief Speaker of today's session. Now, one thing I want to tell you, a brief introduction about the ATAL cell, that our department is running this type of program right from 2018, and I am also the coordinator of this program. In 2018, AICT has decided to organize such programs which are on emerging topics. Now, what are that emerging topics? Emerging engineering topics or emerging some leadership topics. So among emerging engineering topics include artificial intelligence, includes our data science, includes our robotics, the 3D printer, and other topics which are branch specified. So in 2018, 19, 20, 21, 22, even during COVID situation also we have organized online program, and that was all on the emerging topic like data science, artificial intelligence, robotics, and like this. This time I personally have chosen this topic, okay, because now this time it is not completely not offline and completely not online. It is in blended mode. The first week will be completely offline, sorry, online, and the second week will be completely offline. So in the online mode, we will have a lecture, two lecture every day, and half an hour for discussion. If you have any problem, if you have any question, and the second week will be of completely practical session where we would be exposed the practical part of the mentioned topic. So in the practical part, we will learn about how to find out the module efficiency, how to find out characteristics of a solar photovoltaic cell module. Then we will also kept a session, 3 sessions for the development of e-bicycle. We have also kept a session that how solar photovoltaic can be installed for an e-vehicle. So you will be exposed to so much things. We will have a plant visit also. We will have a visit to an electrical vehicle development industry also. So everything you will get it. Just stay with us and enjoy the things. So today we are starting our online session, and I myself, Dr. Vikramaditya, will be the speaker. I welcome each and every person uh, who is eagerly participating in this. Okay, so my today's, let me open the my PPT. So though the session it has made some advances, but advances will get clear only when fundamentals are known to you. Okay, so I am beginning my this session, the first very session on the fundamental of PV system, and the second session of today's will be related to some advanced topics related to the development of the solar PV system. Okay, so all are okay with this? Okay, so how my PPT will focus. I will be covering the following topics: the solar energy basics and solar spectrum. Then so what is photovoltaic cell? What is its construction and working? Then what are the different technologies related to solar photovoltaics? How many types of solar photovoltaic systems are there? Then how to design a solar photovoltaic system? What are the advantage and disadvantage? And what are the application of solar energy? And the next session we will take the what are some advanced topic related to the solar photovoltaic technology. Okay, so the very first question, that the why this energy emitted by the sun is called solar energy rather than solar energy. So I want to clear this misconcept, that basically this word soul was a Latin word. Okay, so these Western people have kept this word as it is, and its energy is being termed as an solar energy rather than the sun energy. So basically this energy emitted by the solar is being generated through a number of thermonuclear fusions are going on. In our lower classes, you might have read about the nuclear fusion and nuclear fission. आपने अपनी छोटी कक्षाओं में न्यूक्लियर फिजन और न्यूक्लियर फिशन के बारे में पढ़ा होगा. तो हमारे जो सोलर में जो एनर्जी लिबरेट हो रही है, हम जिसे देख रहे हैं लाइट के फॉर्म में या हीट के फॉर्म में, वो बेसिकली बन रही है न्यूक्लियर थर्मोन्यूक्लियर फ्यूजन के कारण. ठीक है, और इस फ्यूजन के कारण जो एनर्जी लिबरेट हो रही है उसका जो इलेक्ट्रोमैग्नेटिक रेडिएशंस है, इट इज कंसिस्टिंग ऑफ many waveforms. In fact, it consists of all waveforms which exist in nature, right from UV, visible, infrared, ultraviolet, X-ray, radio. So everything is contained in its electromagnetic radiation. This is the beauty of this solar electromagnetic radiation. Okay, and this energy, consisting of all type of waveforms, have two energies in it, light as well as heat. And you will surprised to know that out of this emitted light by sun, only fraction of the energy is reaching or is absorbed by the earth. Okay, I can explain with a diagram. Okay, that total incoming solar is 174 picowatt, out of which 89 picowatt is being absorbed by land and oceans, and the remaining is being reflected back again in the atmosphere. In short, we can say that whatever the energy we receive, in fact, we receive only 47% of the total solar energy. This 174 picowatt is the 47% of the total energy. It means before reaching the Earth's surface, something is lost in the atmosphere only. And out of which this 174 picowatt, 89 is being absorbed by the land and oceans. And only a few portion, that is 50%, is being reflected back and is being there over above the Earth surface. And Earth, the sun, though it is giant from Earth point of view, ये अपने को बहुत बड़ा विशाल ग्रह दिख रहा है, मगर हकीकत ये है कि ब्रह्मांड में, यूनिवर्स में जाएंगे तो ब्रह्मांड में ये बोलना है. It is being called as a dwarf planet in the universe. Though from Earth point of view, it is a very big planet having very high temperature, and even scientists were not able to reach near to its corner also. Then what to about talk about its surface? इसकी सरफेस के बारे में क्या बात करें, अभी तक इसके आसपास भी हम ना भटक पाए हैं. तो हमारे लिए तो ये बहुत बड़ा एक आग का गोला है. ठीक है, मगर ब्रह्मांड में ये एक बौना है. और इसकी कुछ बातें हैं, खूबसूरत बातें हैं. वो है इसका स्पेक्ट्रम. आप इसका स्पेक्ट्रम देखेंगे तो आप पाएंगे कि दिस स्पेक्ट्रम, जैसा कि मैंने पहले अपनी स्लाइड में बताया, कि ये स्पेक्ट्रम सभी प्रकार के वेव्स को अपने आप में समाहित करता है. इट कंटेन ऑल टाइप्स ऑफ सोलर रेडिएशंस, all types of wavelength in its spectrum, right from UV, this up to 300, it is the UV range. From 300 to 750, it is visible range. And after beyond 750, it is the infrared, and infrared is extending from 3000 nanometer and so on. So all types of waveforms are contained in it. And also you can see that at the black body, where the temperature is about 6000 degrees centigrade near about, that also contain all the waveforms. The absorb the solar radiation absorbed by the oceans is also having all type of waveform, and at the top of the atmosphere also have the all types of wave law. The yellow is by the absorbed at the top of the atmosphere, while black is the black body spectrum, and this the red one is radiation at sea level. So these all points I'm highlighting so that you can see that how powerful, how this solar is its versatile characteristics. Air mass is approximately 1.1. In fact, it is the amount of the air mass through which light passes. Okay, it is 1.1 in our case, and near about 50% of the solar energy reaches the earth. That we have already discussed. Now, the question arises how we can harness this solar energy. Okay, so we can harness this energy in 4 ways. Okay, the solar thermal energy. One is solar thermal energy. I will explain you how is solar thermal energy. It is there. Solar heating is different. Solar thermal is different. Okay. In solar heating, we can have a solar water heater. Okay. It is there in our department also. Then we have a solar space heating. Okay. That is used in generally Canada and UK and all this. Then solar space cooling. That is for the refrigeration.
Excuse me, sir.
Yes. Yes. Anybody? Surendra
I'm
Kumar.
not able to hear your voice.
You are not able to hear my voice.
वॉइस इज लाउड एंड क्लियर सर. उनके इंस्ट्रूमेंट में हो सकता है प्रॉब्लम.
Sri Surendra Kumar Singh ji, you may have a problem in your own instrument, so kindly check it because the other participants are getting my voice. Yes, anybody from the participant other than Shekhar ji, all are getting my voice?
Yes, sir. It is perfectly fine, sir.
Yes, sir.
Okay, sir. Thank you very much,
Yes,
sir.
clear,
Sir,
sir.
सुरेंद्र कुमार सिंह जी, मैं रिक्वेस्ट करूंगा आप प्लीज अपना डिवाइस चेक कर लें. ठीक है, probably there may be some problem in it. It is there, generally happens. Okay, so kindly check it. Okay, sir. Then another way through which we can harness solar energy is by converting in the solar radiation into electricity, and that is called solar photovoltaic, and on which we will be mainly concentrating. And the third is the solar concentrator. Here we are concentrating the solar energy and making and using it thermal energy for some application. So that is called solar concentrator. So the 4 types of technologies are there through which we can harness or harvest our solar energy for different application. Okay. Now, the first one is the thermal energy. Okay. Thermal energy and photovoltaic energy both are meant for the production of electricity. What is solar thermal energy? In the solar thermal energy, heat is being used to heat the fluid. Means the thermal energy is being to heat the fluid, just as the water in case of in case which is put in a very big size like a structure, and there it is heated and it became superheated steam, and this superheated steam is used to run the turbines, which in fact turbine runs the alternator, and alternator therefore generate the electricity. But it is not being used by the common people. It is used by the plants, the thermal plants. Instead of using the coal, or any other conventional fuels, we are using the solar thermal energy to heat the water to convert into super steam and thereby running the turbine. Another is the solar photovoltaic energy, where we are just using the radiations on a particular material like silicon, and thereby the electricity is being generated. Okay, and that generated electricity can run our electrical devices. Okay, so this is the difference between the solar thermal energy and the solar heating. In the solar heating, what happens that we are using the heat to either heat the water, as in our home devices, which is called as a solar water heater. Then comes the solar dryer to heat the crops so that the moisture get evaporated. Just as conventionally we used to place these crops outside the atmosphere in the front of the sun. हम पहले क्या करते थे कि हमारे जैसे मिर्च हुई तो मिर्च को तोड़कर हम सुखा देते थे, उसको लाल मिर्च बनाते थे. अब होता क्या था कि जब हम बाहर सुखाते थे तो कोई पक्षी आके लेकर चला जाता था, कोई जानवर आके खाने का प्रयास करता था, और बहुत नुकसान होता था किसानों को और जो उनको उगाते थे। अब हमने क्या कर दिया है कि ड्रायर बना दिया, एक पूरा प्रकार का पैकेट बना दिया है, और वो भी साइंटिफिक वे में कि हमारा जो सोलर जो कांच रहेगा जिससे हम हीट लेंगे वो एक पर्टिकुलर एंगल पे रहेगा, एक डायरेक्शन में रहेगा और क्लोज फॉर्म में रहेगा। और आजकल हमने ऐसी टेक्नोलॉजी कर दी कि हम उसकी हीट को भी कंट्रोल कर सकते हैं। तो एवरीथिंग इन अ साइंटिफिक मैनर, सो दैट इज कॉल्ड सोलर ड्रायर। सिमिलरली हम पहले भी सर्दियों में गर्म पानी बनाने के लिए अपनी बाल्टी बाहर धूप में रख लेते थे, और फिर जब वो 1-2 घंटे बाद गर्म होता था फिर नहा लेते थे। लेकिन अब हमने क्या किया है कि हमने एक सोलर वाटर हीटर साइंटिफिक वे में बना दिया है, आइदर ट्यूबुलर फॉर्म और फ्लैट पैनल टाइप। ओके, और हमने उसमें कुछ मटेरियल डाल दिए ब्लैक कलर के, ताकि वो बहुत ज्यादा सोलर एनर्जी को एब्जॉर्ब करे, और फिर उस हीट को पाइप में से बहाकर पानी को गर्म करे, और उस पानी को हम नीचे पाइप के थ्रू से अपने टेप में लाकर हम उसका यूटिलाइज कर सकते हैं। तो साइंटिफिक वे हो गया, और उसको हमने सोलर वाटर हीटर नाम दे दिया। उसी प्रकार ग्रीन हाउस भी सोलर की थर्मल एनर्जी यूज करके अपने टेम्परेचर को मेंटेन रख सकता है। तो ये हुआ सोलर हीट का यूज, सोलर थर्मल का यूज और सोलर फोटोवोल्टिक का यूज। कुल मिला के हमारा जो सोलर पावर है उसके पास दो प्रकार की एनर्जी है, थर्मल एनर्जी और पीवी एनर्जी। थर्मल एनर्जी हमारा लो टेम्परेचर लेस देन 100 डिग्री में सोलर वाटर हीटिंग, सोलर चिमनी, सोलर पॉन्ड में यूज हो सकता है। मीडियम टेम्परेचर लेस देन 400 डिग्री सेंटीग्रेड में हो सकता है, और हाई टेम्परेचर ग्रेटर देन 400 डिग्री सेंटीग्रेड में जो कंसंट्रेटर के रूप में यूज आता है। ठीक है, और जो पीवी सेल्स है जिससे हम सोलर थर्मल एनर्जी, सोलर एनर्जी को इलेक्ट्रिसिटी में कन्वर्ट करते हैं, वहां 4 प्रकार की टेक्नोलॉजी यूज हो रही है मेटेरियल वाइज। व्हाट आर दैट? वन इज मोनोक्रिस्टलाइन सिलिकॉन, जहां पर मोनोक्रिस्टलाइन सिलिकॉन ये क्या होते हैं मैं बताऊंगा आपको। ठीक है, ये बहुत जरूरी है, तभी हम आगे एडवांसेस समझ पाएंगे। दैट इज व्हाई आई हैव स्टार्टेड विद द फंडामेंटल। दूसरा है हमारा पॉलीक्रिस्टलाइन सिलिकॉन। तीसरा है हमारा एमोर्फस सिलिकॉन। चौथा है हमारा थिन फिल्म। ये मेरी स्लाइड थोड़ी पुरानी है, आजकल एक नई टेक्नोलॉजी आ गई है, उसका नाम है पॉलीमर सोलर फोटोवोल्टिक सेल। ठीक है, जहां पर पॉलीमर को यूज करके बनाया गया। हालांकि वो कॉमर्शियलाइज नहीं हो पाई क्योंकि उसकी एफिशिएंसी 2 to 3% है, मगर जो मार्केट में प्रिवेलिंग है वो या तो मोनोक्रिस्टलाइन है, पॉलीक्रिस्टलाइन और थिन फिल्म है। अमोर्फस भी, हमारे अमोर्फस सिलिकॉन भी, दिट इज नॉट बीइंग सो मच यूजफुल बिकॉज इज एफिशिएंसी इज वेरी वेरी लेस, दो इट इज वेरी चीप। If you compare mono, poly, thin and amorphous, then this is the cheapest form, and polymer is the most cheapest, but both have the efficiency very very less. The polymer has 2 to 3%, amorphous has up to 6%, so they are not being used. Just for the sake of the historical importance, they are being said that this is also one technology. In India, up to 2020, we were focusing on polycrystalline silicon. But after 2020, now people are moving toward monocrystalline. Though thin films are not being used because from India point of view, it is a costly item and being less used. So we are mainly focusing on monocrystalline and polycrystalline silicon technology. Any question so far? It should be a two-way talk. Okay, if I keep on speaking, then it means that I am just time passing the thing. And if you have any question, it means, or if you have some new things related to it, then do speak it by pausing me. Now, why this silicon only? Okay, because the silicon is being considered as a semiconductor material. Just to revise you the chemistry which you have learned in 12th class, आपने 12वीं कक्षा में जो एक पढ़ा था उसी का एक छोटा सा मैं आपको एक रूप दिखा रहा हूँ कि हमारा जो वैलेंस बैंड है और जो कंडक्शन बैंड है, यदि अगर ओवरलैप करता है एक दूसरे से तो हम उसको कंडक्टर कहते हैं, जिसमें गैप बहुत कम होता है, 0.1 इलेक्ट्रॉन वोल्ट होता है, और कई बार नहीं भी होता है अच्छे कंडक्टर्स में। ठीक है, और एक इंसुलेटर होता है, उसमें वैलेंस और कंडक्शन बैंड में बहुत ज्यादा, देयर इज अ लार्ज गैप बिटवीन देम ऑफ 9 इलेक्ट्रॉन वोल्ट, एंड इट इज वेरी डिफिकल्ट फॉर द नॉर्मल एनर्जी टू ब्रेक दैट गैप. Okay, and that is these type of material called insulator. Then there is another band, there is another material where the gap is very very small, but in normal condition we cannot break that gap, but if we provide sufficient energy externally, we can break this band gap, which is of approximately less than 1 electron volt or somewhat greater than 1 electron volt. And this type of property is present in silicon and germanium, and by applying small energy from external source, we can overlap these band and their conduction can start, and that is why these material are called semiconductor. आधे कंडक्टर है, पूरे नहीं है. नॉर्मली में ये इंसुलेटर है. ठीक है, तो इस प्रकार हमने अच्छा, ये तो मैंने आपको बताया कि एलिमेंट्री जो सेल्स है, दीज आर सिलिकॉन एंड जर्मेनियम. But there are other material also belonging to the third group, fourth group, fifth group, and sixth group also. Okay, and second group also. Okay, these come under the category thin film solar cells. What are they? Gallium arsenide, जो कंपाउंड में लिखा हुआ है. दूसरा इंडियम फॉस्फोरस, कैडमियम टोलराइड. फिर 3 कंपाउंड से भी हम सोलर सेल बना सकते हैं. जनरली एक परसेप्शन है कि हम सोलर सेल से सिलिकॉन से बना सकते हैं. ठीक है, लेकिन मैं आज आपको बताना चाहूंगा कि देयर आर सम थिन फिल्म टेक्नोलॉजीज देयर वेयर यू कैन कंबाइन 2 कंपाउंड्स, 2 materials, 2 elements, and you can form solar cell. They have the same characteristics as silicon, like gallium arsenide. You can combine 3 compound also, layer by layer. That is called aluminum gallium arsenide, mercury cadmium telluride, copper indium galenite, CIS. Then 4 elements also, layers: copper indium gallium selenide, CIGS, thin film cells. These are called CIGS thin film, copper indium gallium selenide. फिर इंडियम गैलियम आर्सेनाइड फॉस्फाइड, इंडियम गैलियम aluminium phosphide. So these are quaternary semiconductors which behave as a solar cell. That is, if solar radiation falls on them, they start generating electricity. Okay, so from now onwards, it is very clear that not only silicon but these compound, ternary and quaternary compounds or element, or these quaternary compounds can also act as an solar cell. Is it clear? Then this is just a brief primary introduction which you have learned in the lower classes, that what is the bond configuration in a silicon. It is you know that there are 4 electrons in the valence shell of the silicon which belong to 4th group element. Okay, and these 4 are being shared by its nearby silicon atom. Okay, and this form a covalent bond, as you can check. This is the way it is framing. Okay, there you can see. Okay, it is sharing these 2 electrons this side and these 2 electrons on this side, and in this way a covalent bond is formed, and the geometry it holds is the tetrahedron geometry. Okay,
सर सिलिकॉन 5 वैलेंसी कोड होता है ना सर? 5 वैलेंसी होता है, 4 नहीं होता.
4 electrons are there in the valence shell, sir.
कार्बन होता है 4 तो नहीं?
नहीं,
कार्बन 4, सिलिकॉन 5 सर.
आप देखिए ना सर, इस पिक्चर में जैसे ये है आपके 1 2 3 एंड दिस इज द 4th वन.
और एक बैलेंसिंग होता है, उससे चेन बनती है सर. फिर
नो, चेन नहीं है इसमें सर, कोवेलेंट बॉन्ड्स है सर. केवल 4 सिलिकॉन एटम्स आर कोवेलेंटली ज्वाइन विद द अदर सिलिकॉन एटम. उसमें 5 वाला तो पेंटावैलेंट एटम डालते हैं ताकि उसमें कंडक्शन की प्रॉपर्टी आ जाए. So these semiconductors are of 2 types. One is intrinsic semiconductors, जिसमें किसी प्रकार की इम्प्योरिटीज नहीं है, वो हमारा इंट्रेंसिक सेमीकंडक्टर है. बिल्कुल प्योर फॉर्म में उसको हम इंट्रेंसिक सेमीकंडक्टर कहते हैं. और जिसमें हमने कुछ इम्प्योरिटीज डाल दी, आइदर ट्राइवेलेंट or pentavalent impurities we have doped in it. This process is called doping. Okay, they are called as an extensive semiconductor. Okay, like arsenic की डाल दी, phosphorus की डाल दी. Okay, then accordingly this doping is being done in order to increase the mobility of the electrons. And in this way, by joining the 2 doped elements, p type and n type, conventionally we have a p-n junction diode. We have learned this in our lower electronics classes, that if we combine p type silicon with n type silicon, then we have a p-n junction diode. Okay, so if this diode can be activated, that is, it starts conducting by some external radiations or by some external source, which generally in this form is solar PV, then this is called the solar PV cell. This is called solar cell. Okay, diode itself is not called a solar cell, don't get confused. But if the PN junction diode is formed in such a way that by throwing solar radiations on it, imposing solar radiation on it, is start actively conducting, then this is called the solar cell. So this type of property is there in some type of cell which we call as solar PV cell. Okay, so this solar cell will have also the same wavelength as the solar spectrums have. Now it is very clear that when these junction diodes are formed, when irradiated with the solar radiations, it start conducting, and we have a PV cell. So when this concept has evolved, let's come to the history. उसके इतिहास को जाने. इतिहास को जानना बहुत जरूरी है, तभी हम है ना वर्तमान को समझ सकते हैं और आगे फ्यूचर में हम बैठ सकते हैं. तो इसकी शुरुआत हुई थी 1839 में. 1839 में इसकी शुरुआत हुई थी और बैकरल, हेनरी बैकरल ने सबसे पहले नोटिस किया था. उसने एक सॉल्यूशन बनाया था. ठीक है, उस सॉल्यूशन को जैसे ही उसने धूप में रखा तो उसने क्या पाया कि सॉल्यूशन के दोनों इलेक्ट्रोड पे एक वोल्टेज जनरेट हो गया. उसे बड़ा आश्चर्य हुआ कि यार ये कैसे, मैंने तो कुछ किया ही नहीं, सॉल्यूशन को सिर्फ जब उसने उसको अंधेरे में रखा, डार्क में रखा, तब उसमें वोल्टेज जनरेट हुआ. लेकिन जैसे ही उसने धूप में रखा, he placed in the sunlight, he found that some voltage is being generated. So he called this effect as a PV effect, photovoltaic effect. Okay, there's some photons has been producing the voltage. Okay, light photons are producing the voltage, so he called it a photovoltaic effect, PV effect. Later on, the same has been found in solids also, silicon also. That was found in solution, but in 1870 it was found in solid also. Okay. Then in 1880, it was found, the PV effect was found in selenium. Okay. Then in 1950, the first the Kaizoxi method was there. The first single silicon crystal was being made to produce the PV. And this PV cell in 1954 was produced in such a way that efficiency of 6% is reached. Now you're surprised to know that at present we have a 20% efficiency, but in 1954 it was having 6% efficiency. But then also it was being used in 1958 in space satellite to power the radio of the space satellite. Later on, it was start using in some low power application which is used in telecommunication like this. Okay, and the process was there up to 2000, that is up to beginning of 21st century, and the present use of the solar photovoltaic in the form of electricity generated started in 2002. Now you will surprised to know that why in 2002 we started using. The only factor is behind is the reduction in the cost. In 1980s, if you are using a solar PV based bulb, then it would have costed rupees 500 or 600 rupees, where that at that time it was the salary of a professor. So a professor was never interested to invest his 1 month salary in purchasing an 1 watt or 2 watt bulb, rather than going for a 1 rupee bulb from the market, a fluorescent bulb. But now the cost has reduced drastically, and now the 1 watt solar is just less than 1 rupee. Okay, so that is why today there is so much sound nearby us regarding the solar PV photovoltaic cell. Okay, so now after in the 21st century era, we are continuously using the solar photovoltaic cell. So let's come to the photovoltaic cell, what it is doing. So PV cell is nothing but it is the junction diode, okay, on which when the electricity falls, it generates electricity, and this effect is called photovoltaic effect. And a PV cell in fact consists of a thin wafer of ultra thin layer of phosphorus dope N-type silicon on top of a thicker layer of boron dope P-type silicon. Okay, so this is the simplest construction of a PV cell. And when the solar energy strikes its surface, then it imparts its photons to create electron hole pairs, and thereby electricity starts generating. Now one more important point I want to focus here, that the electricity so generated is of which type? Okay, this is of DC type. This is of DC type, not, and the electricity we are getting at the home is of which type? AC type. So we have to be very cautious that it is generating DC type, but at present our institutions, our home, our industry, all are using AC type. Hence there should be some mediocre device which will we should convert the DC into AC. Okay. And one important point I want to put before you, that DC devices are more efficient than AC devices. At present, in most of the houses, you were using a 20-watt LED tube light in your room of 10 by 12 or 10 by 10. But you will surprise to know that if you want to same luminosity, you require only a 9-watt DC tube light. So which is more efficient? Yes, anybody from the audience? Which is more efficient, DC or AC? Definitely you will say DC. But then why we are not using DC devices? Why we are not using DC tube light or DC LED tube light, DC fan? The reason behind it that for last 70 years we have set up our infrastructure for AC only. So it is very difficult to make a change and convert everything, wires, devices, supply and everything. So it will take time. But for time being, I will say that DC devices are more efficient in comparison to AC devices. Now, this is the photovoltaic cell operating principle. So there are three basic steps for generation of electricity using PV cell which are following. First is the absorption of the solar radiation. The second is the generation of free charge carrier. And the third is the transport and the collection of charge carrier at PV cell terminals. Okay. So three types of processes goes on here. Okay. Absorption, generation of free carriers, okay, and then its transportation, so that a voltage is being created or electric field is created at its terminal ends. This is the basic principle of it. Now let's come to the structure of a solar cell. This is very important from engineering point of view. Those who are engineers, okay, from their point of view, the structure of solar cell is very important. So we have a different layers. The solar panel which you people have seen in and around your institute or home or this is not simple. A silicon cell is there. There are a lot of things other are also associated with it. The first portion is the cover glass cover is there. Okay, now this should be mechanically strong so that it can bear the vibration and the environmental abnormalities and other things also, like jumping of the monkeys on it. It should not damaged. It should not get damaged. So it should be very hard enough to bear all type of stresses. Okay. Then second, there is a transparent adhesive layer is there. Okay. Just so that there is a difference between the silicon cell and the cover glass. Then there is an anti-reflection coating is there. Now what is this anti-reflection coating? देखिए, अगर आपके सोलर रेडिएशंस आपके सिलिकॉन सेल पे पड़ रहे हैं और जैसे जितने पड़ रहे हैं सोलर रेडिएशन, वो सारे के सारे रिफ्लेक्ट हो जाते हैं. रिफ्लेक्ट होने के कई कारण हो सकते हैं. मिट्टी भी हो सकती है, सैंड भी हो सकता है, तो आपके इलेक्ट्रिसिटी जनरेट नहीं होगी. इज इट क्लियर? हम चाहते हैं कि जितने भी सोलर रेडिएशन उसमें मैक्सिमम हमारी इलेक्ट्रिसिटी बनाए, इसलिए हम उन सिलिकॉन सेल पे एंटी रिफ्लेक्शन कोटिंग डाल देते हैं ताकि वो उन रेडिएशंस को एटमॉस्फेयर में बाहर जाने से रोक सके. और फिर उसके नीचे होती है हमारे सिलिकॉन सेल की लेयर, जिसके ऊपर ये जो आपको लाइंस दिख रही है, दीज आर कॉल्ड फ्रंट कॉन्टैक्ट्स. ओके, और इसके पीछे होता है हमारा बैक कॉन्टैक्ट. So this silicon cell is consist of n-layer semiconductor and p-layer semiconductor, which we already discussed, and there is a back contact is there, and these are being taken out in a junction box, the front contact and the back contact in the form of plus and minus. So in this way a solar cell or a solar module is being formed. Then come another concept called blocking diodes. Okay, what is the blocking diode? Now say this is a panel consisting of so many solar cells. Okay, it is generating DC. I have already told you that panel will generate plus and minus. Okay, and it will supply to this battery. Okay, it will supply to this battery. Now battery will get charged, okay, from sunrise up to sunset. Now after sunset, what will happen? After sunset, what will happen? This panel will not give any electricity because there is no solar radiation is there, darkness is there. Okay, so what you can expect from here? Battery will charge the panel. So charging the panel by battery means damaging the battery. Okay, it will pass electricity through the cell, and cell have is not a, they don't want this electricity, so they will get damaged and they will get burned. So we, in order to stop the reverse flow of current, we provide a diode called blocking diode. We provide a, a diode called a blocking diode. You can see this is called a blocking diode. Okay, so this blocking diode will stop the reverse current and thus will save the silicon cell. Okay, so you might have seen in all the panels a type of diode is there. You might have wondered why this diode is there. This diode is called blocking diode. Then there is another diode called bypass diode. That also we will see in our next slide. Okay, so this blocking diode to stop the reverse flow of current. Then there is a called bypass diode. Now blocking diode just is meant for blocking the reverse current, and the bypass diode is to stop the hot spot creation. Now what is this hot spot creation? Okay, what happens that it is always being recommended that whenever you install the solar panel, there should be no shading effect. आप कहीं पे भी आप सोलर पैनल आप इसको इंस्टॉल करें तो आप आसपास देख लें कि कोई शेडो नहीं आ रही है उसके ऊपर. शेडो आने का मतलब शेडिंग इफेक्ट इज देयर. अब शेडो कैसे आ सकती है? शेडो किसी बिल्डिंग की आ सकती है, शेडो किसी पेड़ की आ सकती है, शेडो आसपास कोई आपने चीज रखी है हाइट में है उसकी आ सकती है. तो ये शेडो क्या करती है, और ये शेडो बड़ी खतरनाक होती है. ये क्या करती है, पूरे पैनल पर शेडो नहीं डालते, कुछ सेल्स में डालती है, और कुछ सेल्स सोलर रेडिएशंस ले रहे हैं और कुछ सेल्स पे शेडो आ रही है, वहां पर सोलर रेडिएशन का इफेक्ट नहीं हो रहा है. तो नतीजन क्या, what happens that those who are getting solar radiation, they will generate electricity and thus will force the cells which is under the shadow and thus make prompt it to conduct it, and he will say, no, why should I conduct yours? I will give my own, I will give you when I will conduct. So in this way a hot spot is generated, and that hot spot is not visible by your eyes. That can be visible through a particular type of camera, only thermal camera. Okay, so they will damage it and your panel will not conduct it. So what happens? You have to connect an diode which is called bypass diode. So what happens? If shedding is there, then the electricity generated will be bypassed and it will be again transferred to the battery. So if you are not interested, okay, bypass it. This is a very good step in life also. If somebody irritates you, if somebody uh, make you to annoy, okay, then it is better fighting with them, it is better that you bypass it. So here also we are using the same thing. We are bypassing our output and passing it to the battery in this way, and this type of diode is called bypass diode. Simple meaning. Okay, I think so it is clear.
Yes, sir.
Okay, so this is another characteristics. I will not discuss much on this. We should bypass diode working. We have cleared it. So that's how the bypass diode looks like. Okay, these are nothing but PN junction diode. Okay, they are also called as an Schottky barrier diode. Okay, they have a special type of specification that the forward voltage and current ratings, the reverse breakdown, these are all kept in mind by selecting a bypass diode. Not all diodes can be made bypass, but with the particular specification only, which are called Schottky barrier diode, can be used as a bypass diode. Okay, now come the most important point, the difference between cell, module and array. Okay, this creates a confusion, and cell, a single entity of a silicon cell is called cell. Single entity is called silicon cell. Now it has a voltage of approximately 0.48 to 0.6 volt, but generally we can 0.5 volt, and the current it can deliver is 5 to 6 ampere. Wattage is between 2 to 3 watt, and its size is about 10 centimeter. Then if I connect these cells in series on a on a base, then it will be considered as a module, and this module may be of 20 to 30 volt, or maybe nowadays 50 volt also, which current ranging from 5 to 6 to nowadays 10 amperes. Wattage can be 100, 200, 300, 400, and you will surprised to know that in Indian market 500-watt panel is also available nowadays. Okay, the size may vary from 1 to 1.5 meter. Then if such modules are being connected in series or parallel, then the so-called structure is called array. This array can have 200 to 300 volt, current ranges from 50 to 200 ampere, and it can be wattage of 10 to 50 kilowatt, and the size is about 30 or to 50 meter, and in fact not 50 kilowatt is the limit, it can be 100 kilowatt or more also. Okay, so these are the three commonly technical words: cell, module, and array are being used. Okay, this is a single cell which is being shown. This is of 2 to 3 watt. This is your module, and this is your array. Module is also called as a panel. Module is also called as a panel. So I think so it is very clear what is cell, what is panel, and what is array. Now, what are the materials for solar cell? Okay, there are so many materials we have already discussed. The silicon in three forms: monocrystalline, polycrystalline, and amorphous. Then we have compounds, binary compounds, cadmium telluride. We have ternary compounds, copper indium diselenide, gallium arsenide. Then we have also CIGS, copper indium gallium selenide, that is quaternary compounds. Zinc sulfide. These are all the materials which are being used for the solar cell. Depends upon the availability. And you will surprised to know that in India we don't have the availability of the silicon. It is being imported either from Germany or from USA or from China. That is why this technology is costly for our Indians. Cell efficiency is concerned. Okay, the monocrystalline, as I've already told you, pure and efficient, and the efficiency reach up to 20%. Though I mentioned 15 to 90%, but nowadays it is 20%. These are polycrystalline or multicrystalline. Okay, they are less expensive, but efficiency maximum up to 16%. Then we have a non-silicon based like thin film, or which include amorphous and copper indium gallium selenide of this. They have a less efficiency. Okay, now the thin film technology is somewhat less expensive, but efficiency very less, so it is seldom being used in our country like India. Okay, however it is very beneficial where the cold, where large cold is there, like in Europe and all this. Then there are certain performance criteria through which you can differentiate between different technologies, like optical property, electrical property, manufacturing property, and performance. So we will not go in detail with this, but these are some criteria through which you can compare it. Then this is the band gaps. Under optical properties, the band gap how vary. For example, crystalline silicon have band gap of only 1.12 volt, while copper indium gallium selenide have a band gap of approximately equal to crystallized silicon, 1.1 electron volt. Cadmium telluride has a very high band gap. Gallium arsenide is again very high. Even the silicon hydride is also very high band gap. So according to the band gap also, these are being differentiated. So let's come to some important point. Now let's come to the monocrystalline silicon modules. Okay, now how to differentiate between monocrystalline and polycrystalline? The one thing is by the color differentiation. Okay, either you check the properties, but it will take time. The polycrystalline generally they are in black in nature, they are black in color, while the polycrystalline are blue in nature. So this is the one way of differentiating between monocrystalline by physically checking it. Okay, but they are very expensive because they are very pure form of silica. Okay, but nowadays the difference has reduced a lot, so that is why in most of the Indian institutes where solar PV are being installed at present are using monocrystalline panels. This is the polycrystalline silicon module. Okay, it is blue colored form. Okay, and has a aluminum electrode which is silver colored wire. It seems to be silver, but it is silver not. It is aluminum electrode front contact. Okay, the back contact is a P type, which is also the aluminum type. Now, the manufacturing technology, in fact, required the less investment. Therefore, they are cheap, but the efficiency ranges up to 15 or 16%. Okay, and they can be also available either in circular shape or square shape. So you can see the two modules. One is black in color, that is monocrystalline, and another is the polycrystalline. They are of the same size, but the efficiency of this is higher. That is, it can generate 128 watt while it can generate only 120 watt. Now, one thing you keep into mind, that this wattage rating is not the overall, that it is not the wattage rating which it provides every time. It can provide, this is the peak rating. When I say a module of 200 watt, it means this is the peak value of it, and this peak value will be generated when full solar radiations are available between 12 to 2 p.m. during the non-cloudy days. Now, there is the amorphous thin film cell. They are very cheap. In fact, from the powder only they are being made, but their efficiency is very less, 6 to 8%, and they are being less mechanical strength also, and that is why they are being seldom used for any applications. So we will not go for the different types of the manufacturing technologies. Okay, rather than we should jump to I will comparison of monosilicon, polysilicon. So from this basis, so far whatever the data I provided, you can compare it from efficiency point of view. You can compare it from their manufacture. It is the monosilicons are being manufactured from single crystals, while they are by fusing different crystals of silicons, and these thin films are by depositing the different layers, as CGS for copper layer, then indium layer, then gallium layer, then uh, selenide layer. Okay, so like this, layers by layer formation is there. Then monosilicon at standard temperature condition performance best. Its performance of polysilicon is moderate, while performance of thin film cell is very good at particular temperature. Area requirement for monosilicon is less, even for poly. Okay, but large area is required for thin films. So likewise, there are so many comparison is there. So with this comparison, the people generally go for a good efficiency with less cost. So up to 2020, this was being available, these all facilities was available in polycon silicon cell. But after 2020, that is after COVID-19 situation, the monocrystalline panels cost has drastically reduced, and the difference between poly and this just of 5,000 or 6,000 rupees is there. So people are going for nowadays polycrystalline cells only. Okay, so this is the direction of current inside PV cells. So uh, so it seems to be a direction reverse. Okay, from N to P. Okay, because the current direction we conventionally assume is like this only. So this is the direction of the current. Now next come the current voltage curve. Okay, this is a very important characteristics, and that we will do practically also. How to plot the IV characteristics of the of a silicon cell or a panel or like this. Okay, we have a power analyzer in our laboratory through which you can connect any panel or any cell, and accordingly you will get this type of character. This is the peculiar characteristics of a this is the peculiar characteristics of the IV characteristics of the solar cell, where you will find that at this it is constant, then there is a point called maximum power point, and then it has a zero current with some maximum voltage. These 2 points where voltage is zero but current is maximum is called short circuit current point. Then this point, maximum point of the x-axis, where current is zero but voltage is maximum, this is called open circuit voltage. But we are neither interested in a current which has voltage zero or a voltage where current is zero. We are interested in a point where maximum power flows, that is voltage multiplied by current. So this is the point. So this is the point.
ये सुरेंद्र सिंह का मोबाइल वो ऑन हो गया म्यूट कराना पड़ेगा उसे।
Okay, okay. Mr. Surendra Singh ji, please can you mute your mobile? It is creating noise. So this is the maximum power point. This is power point where we have a sufficient voltage and sufficient current, and in all we have a maximum power from the circuit. Okay, and this is the equivalent circuit diagram of that. Definitely you will ask us how to represent a diode, how to electrically represent a solar cell. So it is represented like this. The current source is there. Okay, the diode is connected in a reverse bias form. Okay, and this is the shunt resistance, and this is the series resistance, and this is the load resistance which is connected at this terminal. So this is the equivalent circuit diagram uh, presented by the different scientists, meant for all theoretical purpose. Okay, where it has been treated as a current source rather than a voltage source. Okay, now the what will be the effect of insolation? Insolation means the radiations per meter square emitted by the sun on the earth surface. So what will be the effect on the short circuit current or open circuit voltage when insolation is increased or decreased? So you can see that if the solar radiations are increased, then short circuit current increases. Okay, that you can see it. Okay, but the open circuit voltage remains same. If you decrease the insulation, the current is reduced, but the open circuit voltage is same. So the insulation has the effect on the short circuit current, but not on the open circuit voltage. This is the point. However, the maximum power point will shift. Here, the maximum power is available is high at a higher point, while here the maximum power is at the lower point. So what I want to say that the insulation has the effect on short circuit and thereby on the power, but not on the open circuit voltage. Okay, so I think so it is clear. Now cell size. Okay, is cell size is going to affect it? Yeah. Okay, so depends upon cell size. If it is a if you are providing same insulation, okay, then the cell size short circuit current may be higher. If cell size is small, its current may be lower. Okay, so depends upon solar insolation also and size also, the total short circuit current and the open circuit voltage may differ from cell to cell. So in this characteristics, you have seen VI characteristics also. This is the VI characteristics. Okay, and this is the power characteristics, power PV characteristics. So you can see that we get a maximum power here at this point. Okay, which we have marked on the IV characteristics. Now we have obtained on the PV characteristics also. Okay, so we are always interested on this point, and this is only the rating of the panels. When I say 200 watt or 250 or 300 watt, this is the P maximum. That is, it can give the maximum power when the maximum solar radiations it will receive. Okay, so curve has been drawn for a resistance of value 0.05. So we can see that we are always interested in this maximum power point rather than the I short circuit or V voltage. Just through by inserting a resistance, we get a straight line at the maximum power point. Now, effect of temperature. Now, what do you think that how temperature is going to affect the IV characteristics? Is power is going to increase by increasing the temperature or it is going to decrease? A general perception is that as we increase the temperature, the power will increase. But this is a misnomer. Okay. Up to certain extent, as we increase the temperature, the power increases. But beyond a particular temperature, the power decreases. So A perception is there among the common that in the Jaisalmer or Badmer district during the summer season, if the temperature is 50 or 55 degree, then it will generate a large amount of solar energy. No, it is not there. It is going to damage your silicon, and therefore the power will reduce drastically. And this you can infer from the fact that your computer room is always associated with some AC. The reason behind it that the silicon chips which are being used in the processor of the computers cannot tolerate a temperature beyond 40 degrees centigrade. However, the silicon which are being used in solar cell, they can tolerate a temperature up to 45 degree, but beyond 45 degree, they start degrading their performance and we get a less output. So temperature up to a particular level is going to increase it, but beyond that particular level, it is going to reduce the output power. Now, effect of shading is also there. You can see that effect that the insolation decreases, low insolation or by due to the shading, you can see the short circuit current is reducing, keeping temperature constant. Okay, the here it is 5, here it is near about 4, then 3, then 2 and 4 and like this. While the open circuit parameter, the open circuit voltage parameter is constant, but the current value is reducing and thereby the output power is reduced because of the shading effect. To have a more focus on shading of modules, you can look towards this, that this is being completely shaded. So the output of this PV module is 0, while the partially it is being shaded. No doubt the power module will be less than the full power when there is no shading is there. देन देर कैन बी सीरीज पैरेलल कनेक्शन ऑल्सो, जैसे रेजिस्टेंस में हम सीरीज में कनेक्ट करते हैं और पैरेलल में कनेक्ट करते हैं, तो यहां पर भी हम सीरीज में कनेक्ट कर सकते हैं और पैरेलल में कनेक्ट कर सकते हैं. आप देख सकते हैं कि यहां पर हमने सीरीज में कनेक्ट किया. सीरीज में कब कनेक्ट करेंगे? जब हम हायर वोल्टेज देंगे. हायर वोल्टेज चाहिए तो इन सीरीज वोल्टेज गेट एड अप. जैसे ये 15 वोल्ट का, ये 15 वोल्ट का, ये 15 वोल्ट का है. 15 प्लस 15 30, 30 प्लस 15 45, and in this way we will get a 45 voltage by adding connected in series. Now if we want, but current is same, you see the 3 ampere is there, 3 ampere is there, 3 ampere is there. However, if we want same voltage but current to be added, then we go for parallel connection, same as in case of रेजिस्टेंस. तो 15 वोल्ट 15 वोल्ट 15 वोल्ट को हमने पैरेलल में कनेक्ट कर दिया, तो वोल्टेज हमें 15 मिनट में, लेकिन करंट तीनों 3 एम्पियर दे रहे, तो हमें टोटल करंट बैटरी में कितना जा रहा है? 9 एम्पियर. सो अकॉर्डिंग टू योर एप्लीकेशन यू कैन कनेक्ट इन सीरीज पैरेलल आइदर इंडिविजुअली और इन अ कंबाइंड फॉर्म आल्सो. तो जो हमारे रूफ टॉप पे जो पैनल्स बने होते हैं वो सीरीज पैरेलल अरेंजमेंट में कनेक्ट होते हैं. जैसे हमारे इलेक्ट्रिकल इंजीनियरिंग डिपार्टमेंट में जो 100 किलोवाट का प्लांट है, उसमें हमने सीरीज बना रखी है. 25 पैनल्स 250 वॉट के हमने 25 पैनल्स हमने कनेक्ट कर रखे सीरीज में, और ऐसे 25 सीरीज हमने 16 पैरेलल पाथ बना रखे, और इन ऑल हमारे टोटल 400 पैनल्स यूज हो रहे हैं. अब एक क्वेश्चन आता है कि सर है ना, एक सोलर पीवी प्लांट कितना एरिया घेरता है? हाउ मच एरिया इज रिक्वायर्ड टू इंस्टॉल द पीवी प्लांट, rooftop PV plant or ground based PV plant? Though this data is old because now some changes has been made, but as an approximate level you can assume that a 1 kilowatt PV plant will need about 10 meter square of area. That is 100 square feet of area is required. But now since PV of 400 or 500 watt are also available, so now it has reduced to 8 meter square. So between 8 to 10 meter square is required for 1 kilowatt of PV. Okay, and accordingly for if you have an area of 200 meter square, so on the same meter you can say I can install 20 kilowatt PV solar photovoltaic plant. So you can decide according to the area. If you are a billionaire and have a very good bungalow, you have a very a great area of rooftop, you can install 10 kilowatt, 20 kilowatt, 30 kilowatt. But there will another important factor will come, and that is your how much you are consuming also. छोटी सी बात करेंगे कि सोलर पैनल को खरीदने से पहले हमें बाजार में क्या क्या स्पेसिफिकेशन देखनी पड़ती है. हमें कई चीज़ों को देखना पड़ता है। सबसे पहला आता है हमारा मैकेनिकल स्पेसिफिकेशन, ठीक है। मैकेनिकल स्पेसिफिकेशन में हम कौन से टाइप का सोलर ले रहे हैं, हम मोनो ले रहे हैं, पॉली ले रहे हैं या थिन फिल्म ले रहे हैं। दूसरा आता है हमारा डायमेंशंस, ठीक है। डायमेंशंस आता है कि हमारे जो सेल यूज हो रहे हैं उनके क्या डायमेंशंस है। देयर आर स्टैंडर्ड डायमेंशन इज देयर दैट दीज आर आइदर ऑफ 4 इंचेस और 5 इंचेस लाइक दिस, so that we can say yes, the manufacturer is from some standard company. Okay, then come the module dimension. Now module dimensions, length and breadth, length and height will depends upon how many solar cell are connected in series. It can be a 36 cell, it can be a 72 cells, or it can be a 144 cells. But the main important find is breadth, that is width. If this width is less than 35 mm, then this solar is not going to perform well. In fact, the new criteria is that this width should be of approximately 40 mm. Then only you can have a good performance of this solar panel. Okay. Then some another specification, the module weight. In fact, modules, most of the are of between 15 to 17 kg. Okay. Then the glazing of front glass. Okay. It should be a tempered glass, as I have already told you that it has to bear the vibration of the wind, the vibration, the infant, the animals like monkeys, if they just swing on it, then it is able to bear that stress also. So tempered glass should be of the thickness 3.2 mm should be used. The frame is generally made up of some cheap material, but it should not get deteriorated in the environmental condition, so it is generally made up of an anodized aluminum alloy. Then the output cables. Okay, so here I have just given an example of Redox smart cables, but you can use according to your country specification cables, but that should be according to the current rating of the output of the solar panel. Then junction box, it should be IP67 rated with 3 bypass diodes. Then come the electrical specification. As I've already told you, the peak power is the first specification. Okay, that is the maximum power of the panel. Then there is the optimum operating voltage, that is the voltage maximum, that is the voltage at the maximum power, VMP. So this is maybe 36, 38, 40 according to the maximum power of the panel. Then there is a optimum operating current also, and these all are at STC. Mind it, what is STC? Standard temperature condition. Okay, which is generally considered as a 25 degrees centigrade temperature and 1.5 atom mass. Okay, and this current is generally varies from 5 to 8 ampere. Okay. Then another is open circuit voltage and short circuit current, which we have already discussed in our IV characteristics. Okay, these are also being mentioned in the solar panel specification. Module efficiency is there. Which type of module efficiency you are using, accordingly you can infer it whether it is a polycrystalline, monocrystalline or thin film. Operating temperature are generally mentioned from -40 to 85 degrees centigrade. Fuse ratings are also being mentioned because fuses are being connected so that in case of high current they get fused. Power tolerance, then the parameter defined NOCT and STC. STC is very clear. This is a standard test condition where the solar radiations are near about 1 kilowatt per meter square. Temperature is 25 degrees centigrade. Air mass is 1.5. Then come nominal operating cell temperature, where irradiance is 800 watt per meter square. Ambient temperature is 20 degree and speed is 1 meter per second. In addition to the last specification, which is associated with the solar panel electrical specification, temperature coefficient, the possible rate of change of values which are being mentioned under varying module temperature, because sometimes module temperature get heated up due to flow of current, then how much it can vary, that also either with the temperature or with the irradiation, that is also being mentioned with the solar panel. So I will take a 5 minutes, 10 minutes break. Then we will start with some more topics related to it. In between, if any question is there, then we can take that question. Anybody have any question, please? So
Not from my side, sir.
I will meet after a 10 minutes break. At present is 8:30. We will meet at 8:40. Till then, you can have your own refreshments.